Okay, so it is recording now. So on the master cylinder, the two ports that we're talking about, the replenishing port and the compensating port. We'll talk about the replenishing port in a second, but the compensating port is open to your brake lines that lead off to your discs. And on the secondary side, there is another compensating port and another replenishing port, and that's open to the drums. Okay, now why do we need that? Well, here's the thing. When you use your brakes, the brake fluid is going to heat up just like your brakes do. Okay, the brake fluid in the wheel cylinders, the brake fluid in the caliper pistons, it's going to warm up. And what happens when it warms up? It expands. If that expanding oil was trapped in the brake circuit, what would that do to the brakes? It would make them drag. So rather than have that happen, we have these things called compensating ports, and it lets that expanding fluid vent back into the master cylinder reservoir. Okay. So what could cause problems with this system that we're talking about? What could cause the oil to not be able to go back through the compensating port? Well, maybe your brake pedal isn't fully releasing. If you always got your foot, hovering on the brakes there, or if something is misadjusted in the linkage that operates the push rod for the master cylinder. So very important that the master cylinder is fully retracted so that the compensating ports can be open. Okay. When you apply the brakes, what you do is you move the pistons forward, and they both move forward. Okay. So initially, the disc brake or the master cylinder that's going to be operating the disc brakes, this piston here is going to close off. And as soon as this piston here closes off, it starts building hydraulic pressure in the master cylinder. Okay. And that hydraulic pressure is used to apply the disc brakes, but it's also used to push on the secondary piston. And the hydraulic pressure on the primary side pushes on the secondary side, which causes pressure to build on the secondary side, which is used to apply the drum brakes. Okay. So you can see that it's actually hydraulic pressure that moves the secondary. It's not moving the master cylinder primary piston far enough to physically hit the secondary and move it. That's not what normally happens. It's normally the hydraulic pressure that makes them. So if that's the case, why do I have this extension on the primary piston? I'll tell you. Let's say that my brake fluid is leaking because I broke one of my brake lines going to the front brakes. So fluid is leaking out. Every time I hit the pedal, it leaks out. Well, if that was the case, that means I could never build the hydraulic pressure necessary to operate the secondary piston. But the primary piston will move far enough until it physically contacts the secondary, and then the secondary pressurizes, the rear brakes work, and we bring the vehicle to a stop. All right. Now, when this happens, you're going to have an operator complaint, and that's going to be that my brake pedal, it just moves like half the travel is just, there's nothing there, and then all of a sudden I got some brakes. You're like, oh, okay. So that means you only have one of your braking systems working. What about if the problem was on the secondary side? What if that was just draining? Well, interestingly enough, the same thing happens. So your master cylinder primary piston is going to pressurize, and it's going to send fluid to the disc brakes. But there's no resistance on the secondary side, so your secondary piston is going to fully collapse before the primary side really starts to build any real pressure. So once again, your pedal goes about halfway down to the floor, and then you get your brakes. Okay. I'm going to get all this stuff off of here, and we're going to talk about the replenishing port, because we've talked about how the master cylinder works. We've talked about why we need the compensating port. But what's that replenishing port for? Well, when you apply the brakes, the pistons both move. And when the pistons move, the piston cup, which is the seal, is going to be somewhere over here. Okay? And it's trapped all the fluid, but sometimes you need to get a little bit more fluid into the brakes. Let's say that You apply your brakes, and you let go of the pedal, and you apply them again. We don't ever want a void to form in the hydraulic system. You don't want to effectively cavitate that when the brake pedal's coming back. Okay, and we also want the brake pedal to be able to come back nice and quick, so that the brakes don't lag when we let off the pedal. So the replenishing port helps to make sure the system stays full and doesn't cavitate. And the primary piston cup, it is just like it says, it's a cup like this. Okay, so that means that when I'm pushing and building pressure, it kind of opens up and it seals better. But when the piston retracts, that cup kind of sucks in, and the lips of the cup come again away from the wall of the bore in the master cylinder. And the piston moves back with, effectively the seal's not there anymore, right? The replenishing port makes sure that there's always a surplus of fluid behind the piston, so that when the piston moves back, if there's any need for extra fluid in the hydraulic area here, like the forward-facing area of that master cylinder piston, we just make sure that oil can get there if it needs to. We're not relying solely on the compensating port to supply oil to that area, right? So your replenishing port, what's it there for? It's there to make sure that the master cylinder stays full in front of the piston when it's retracted. So here's another thing for you. And actually, I'm just going to ask you a question. Has anybody here ever replaced a master cylinder on a hydraulic brake system? Yes or no? Yeah? What do you need to do when you replace that master cylinder? You just slap it on, hook the lines up, and you're good to go.
I normally fill it up before it's on the vehicle.
So filling it up, yes. Is there anything else that you'd normally do before you put it on the vehicle and hook it up to the brake lines?
Well, you gotta bleed it.
Okay.
So within reason.
And bleed it as best you can. And whenever you buy a master cylinder, what you end up with is these, they're usually little plastic fittings that'll thread into these ports, right? And they've usually got that little nose on them, that little barb fitting. And then there's a hose that you loop, you hook up to that and you loop it back around into the master cylinder. Okay. And then you put this thing in a vise, and then you just pump the push rod back and forth several times until there's no bubbles showing in the hose. All right. Now, the reason why we do that is because if we didn't do that, you would just have air in here. And then when you're trying to bleed your brakes, you'd have to basically force all the air from the master cylinder through the entire brake system before it would be bled, which is not very easy to do. Okay? The other solution to this, where you wouldn't necessarily have to do this, is if you bled the brakes in reverse. What I mean by that is where you force fluid through the bleeder screws. So you pump fluid in at the bleeder screw and it comes back out of the master cylinder. All right. But I would recommend that you always bleed your master cylinder before you install it to make sure that these cavities here are full of fluid and not air. Now, there is another thing too that we should talk about. And this is a modern day problem. This is not something you would have had to worry about on older vehicles. If you have ABS, the fluid doesn't go straight from the master cylinder to the wheel cylinders, does it? It goes through ABS module first. Your ABS module has got a pump and a series of valves in it. And if you get air trapped in the ABS module, your normal bleeding procedure will not be effective. Okay, and there is no getting around this. So make sure that you bleed your master cylinder properly first and make sure you don't have air in the system. Bleed your brakes. If you have ABS, you may have to operate the ABS pump in order to bleed it. How do you operate the ABS pump with a vehicle that's not skidding?
Probably have to hook a computer up to it, I guess.
You have to have a scan tool, and I'm not talking about your $30 Canadian Tire Princess Auto scan tool that pulls codes for you. You need a real scan tool that has two-way commands on it. What that means is you can tell it to do stuff to the engine or to the vehicle, right? So if you have a scan tool that's capable of doing that, it's going to have a brake bleed function. And the brake bleed function on the tool, you just go through, select your vehicle, set it up, tell it that you want to do some tests and commands, and you go scroll down to one where it's a brake move function. And when you turn that on, it operates the ABS pump. And it'll walk you through a series of steps to run the ABS pump and then bleed the air out downstream from it. But if you don't do that, there's no way to know that you got all the air in the system, and you're going to have spongy brakes. And it doesn't matter how good of a job you do bleeding them, they're still going to be spongy. Okay, so just be aware of that, guys. Let's see what else we got here. So master cylinder could be divided up front and rear, split diagonally. We don't split them diagonally anymore. Okay, you got disc brakes up front, you got drums or discs at the back, and generally we have it set up such that the primary operates your discs and the secondary operates your drums or your rear brakes. Okay. So over here, we've got a picture with some text, and it's showing us that we have the same stuff. We're calling them vent ports, compensating ports. Sometimes there is different terminology for the exact same thing in this trade. Just be aware of that. The replenishing ports are just behind that, just like in the other example I showed you. One thing that's been missing and that I didn't talk to you about on the other diagram, and it's not on this one, is if you have drum brakes, you're going to have your residual pressure check valve mounted to the master cylinder on the circuit that feeds the drums. Okay, there will be that residual pressure check valve. There will not be one if it's feeding disc brakes. Okay, here we're just looking at a walkthrough of when things are applied. And here we're looking at a bit of a walkthrough on a purpose of the replenishing port. And like I said, it keeps the area behind the piston full of oil so that when the piston is moving back, when you take your foot off the pedal, the piston cup is just going to kind of fold up, and it's going to let that oil circulate to the front side of the piston. Okay. A residual pressure check valve. Make sure you know what that thing is and what its purpose is. It's to hold a little bit of pressure in the brake circuit that's used to feed drum brakes. It's usually around 12 to 15 psi. And the reason that's there is to keep some pressure on the seals so that the wheel cylinder cups don't collapse and cause leakage inside your brakes. All right. Wheel cylinders will leak if that residual pressure check valve is missing. Disc brakes will drag if somehow you had managed to hook up disc brakes to the circuit that was supposed to be servicing the drum brakes. Because disc brakes, they don't need that pressure. And in fact, there's no springs to pull back the piston on disc brakes, is there? So if you keep 12 to 15 psi on it, it's going to drag. Just be aware of that. Now we're getting into some of the other valves. Okay, there's a couple of different valves, and we're just going to go through them and talk a little bit about what they do. Proportioning valves. We've already discussed that some of the, a lot of the brake systems are set up such that we're able to have more braking force on the front than the rear. And the reason for that is the weight transfer as the vehicle dives, as the braking force increases. So it doesn't make much sense to have a lot of braking force available to the rear wheels if there isn't a lot of weight on the rear wheels, right? So if we had a proportioning valve, the whole idea there is to make sure that during light brake application, front and rear brakes do have an equal amount of pressure to them. So we have uniform braking front to rear. Under heavy braking, where there's higher pressure in the brake circuit, we cut off oil pressure to the rear and just maintain whatever was already there, and we continue building oil pressure to the front. And that lets us give more of the braking force to the set of tires that have more of the weight on. That's what a proportioning valve is for. The reason we do it is so that the rear wheels don't lock up. Okay? Your proportioning valve is sometimes just a simple, you hit a certain pressure and then we limit rear braking force. Other times, it is a regulated proportioning valve, and what that really means is that it's a valve that is going to change how much it varies the available pressure to the rear based on suspension angle, which is directly related to how much the front of the vehicle is diving because of hard braking. I don't know if you guys have ever seen this or not, and this is an automotive thing almost exclusively, but sometimes there's a little linkage to the rear suspension and it goes to a valve that's in your brake line and you're thinking, what the heck is that for? That's what it's for. Okay. It is a linkage that the more the rear suspension drops compared to the body of the car, because it's diving, right? The more it restricts brake pressure available to the rear wheels. That's a regulated proportioning valve. If you had a diagonal split, you'd have two of them, but let's not even worry about that because it's not really much of a thing anymore. So where does that proportioning valve go? On this picture here, you can see that we actually have a couple of different things, but the proportioning valve on this one would be this guy right here. Okay. And really all that happens is as the pressure builds, it's going to be allowed to flow. The oil is going to be allowed to flow through to the rear brakes. And once the oil pressure gets to a certain predetermined value, this piston moves up and it blocks off the oil. As soon as the pressure goes away here, this valve opens and we allow the oil back. Okay. There's two other valves shown here. This metering valve is one, and the pressure differential valve is another. Okay, we'll talk about those two as well. So a metering valve. What exactly is a metering valve and why do we need it? Well, there's a little bit of text here that shows, and I think what I'm going to do is I'm going to hop back to this picture and we're going to talk. Okay. So if we take a look at this picture right here, the metering valve, it's kind of like a little relief valve in a way. Okay. So let's think a little bit about this. If I apply the brakes, assuming of course that I have rear drum brakes, not rear disc brakes, when I start pushing down on the brake pedal, I already have 12, 15 psi of pressure in that hydraulic circuit, don't I? And I also have to overcome that pressure plus whatever that spring tension is that's holding those shoes retracted. So that means there's going to be some hydraulic pressure necessary before those shoes even start to apply, right? But remember too that I said that my front brake circuit is basically running straight, unrestricted to the calipers for the disc brakes in the front. And that means that as soon as I create any pressure, those pistons are going to start pushing out and the pads are going to start grabbing the rotor. So that would mean that, if there was no metering valve here, the front brakes would apply before the rear ones. And if I don't have uniform braking front to rear, that can cause, uneven braking and vehicle control issues, right? So what the metering valve does is it just acts like a little relief valve, okay? Initially it's closed. And we have to build up a certain amount of minimum pressure before this valve will open and let pressure to the disc brakes, all right? The reason we need that is so that we have balanced braking front to rear. That's your metering valve. Okay, so basically everything that I just said is there. Here we do have a little bit of information about the metering valve. And one thing that you should be aware of is if you do have a metering valve present in your braking circuit and you know why it's there and what it's doing, it's there to stop oil from going to the front brakes. When you're trying to bleed the brakes, it's going to stop oil from going to the front brakes. Do you see the problem here, guys? You got to make sure it's open. Okay. So again, I'm not going to tell you that every single vehicle is going to have something like this you're going to have to deal with, but I'm telling you that if it's there, be aware of it. Okay. Check your service information, figure out where it is, and figure out what you got to do to open it. Here we have a little bit of information about how to open it. Okay. But I'm not going to say that this is the way it is for every single thing. If there's a metering valve, make sure it's open when you're trying to move the brakes. Okay. If there's no metering valve, no concern. Uh-oh. I think I just closed the wrong one, guys. My bad. So I'm just going to go. Give me a second here. I just gotta pull that back up on the screen, okay? Jump down to,
I think we were on like 45 or something.
okay. There we go. Okay, thank you. So we were just talking about metering valves. We're talking about making sure they're open. And then here we are at the pressure differential switch. Now, the pressure differential switch is something that we have on our braking system. And it's there to operate the brake warning light. Okay, so the brake warning light, you know how you have that little brake light that comes on when you push on your park brakes? Okay. Now, if that brake light comes on and your park brakes are released, or if your brake warning light or message comes on your dash, it's there to tell you that there's a problem with your brakes. Okay. Now, what exactly is it doing and how does it work? Okay, so we have, let's skip up to my other picture here, because I like this one a little bit better. Okay, so we have this pressure differential switch, okay, and it's a piston right here, and that piston is exposed to both the braking circuits. All right, and assuming that both of the braking circuits are operating properly, that means that the pressure in both of them should be the same, right? If there was a problem with one of them, let's say that we had a leak in one of the rear brake lines, or one of the rear brake lines is broken, and the pressure in the rear is not the same as the pressure in the front. So if the pressure in the rear isn't the same as the pressure in the front, that means that this piston, which is this guy right here, is going to end up shifting up. And when it shifts up, it operates a plunger that pushes in on a switch and closes a set of contacts that goes to the brake warning light on the dash, right? When that brake warning light turns on every time you hit your brakes, it's doing that because that pressure differential piston moved, because there was a difference in pressure from one side to the other. It turned the light on, and it's indicating that there's a fault with the brake system. Okay. So here we're just looking at how that works, a couple of different diagrams. If we do have a valve that combines the functions and features of the three separate things that we've been talking about, the proportioning valve, the metering valve, and the pressure differential switch, we would just call it a combination valve, okay? Anti-lock brakes. You can't really have a conversation about brakes nowadays without talking about anti-lock brakes a little bit. Okay. I am not going to talk about anti-lock air brakes in this conversation. We'll save that for the lesson that we're talking about air brakes. But when we're talking about anti-lock brakes in the context of hydraulic brakes, you're going to have a couple of different bits and pieces that make up this system. All right. So anti-lock brakes, first of all, what do they do and why do they do it? Well,
Locking up and sliding, right?
it keeps your wheels from locking up and sliding. Okay. Now, some people love to lock up their tires and have no directional control because they think it makes them stop faster. Now, does it make you stop faster? Not really. It might feel like you do. You're not really stopping faster. Okay, not necessarily.
Everyone in here is beeline if ABS hasn't saved their ass at least once or twice.
Now, do you like
That
the
old
way it
truck
feels?
gets fucking no. Like that old truck's terrifying in the winter, and I'd much
ABS
rather drive the
systems.
new one.
ABS systems are a lot more sophisticated now than they were 20 or 30 years ago, you know. But what I will tell you though is, yeah, I don't like it when that pedal starts pushing back up at me. I'm like, no, I want brakes. So I'm pushing and it's pushing and we're fighting, right? Do you like that? No. But can I still steer the vehicle so that I can hit the snowbank instead of the guy in front of me? Yeah. Okay. And that's what it's all about. It's about maintaining static friction between the tire and the ground. And if there isn't much friction to be had because the roads are icy, well, it doesn't really matter one way or the other. You're not going to stop. Okay? And static friction is greater than kinetic friction. Remember that. So if your wheels are sliding, there's actually less friction between the tires and the road than if they're rolling. Okay? So how does the vehicle know that one of the wheels is trying to skid? You have ABS sensors, they're wheel speed sensors. Okay? And those wheel speed sensors are they're really just little usually VR type sensors, and we'll get into different types of sensors and how they work in future levels when we get into sensors and electronics and so forth. But they are a little speed sensor. Okay? And the way that they work is they generate a pulse every time a tooth of a tone wheel goes by them. Now, a tone wheel, if you ever looked at that ABS trigger ring, that's what I'm talking about. Okay? So that ring, it just looks like a ring of steel, or maybe it's just a bunch of notches or teeth on an axle shaft. The whole idea there is we have a way to create a bunch of pulses, measure and count those pulses, and figure out how fast the wheel is turning. If I've got an ABS system where one of my wheels is skidding, the ABS module is monitoring the wheel speed by counting the pulses. And if it recognizes that one wheel is stopped or turning slower than the others, it may trigger the ABS. And what does the ABS do? Well, we realize that there's an ABS pump. Yes, there is an ABS pump, and there's valves as well. And the ABS pump takes over for the master cylinder in terms of providing the pressure to apply the brakes. Does that make sense? So instead of the master cylinder being the thing that's running the brakes, now it's the ABS pump and the valves inside the ABS pump that send the pressure and control the pressure to the wheel cylinder. Okay. So when that ABS pump operates, it's going to be sending pulses of pressure to the wheel cylinders. And if we don't need as much pressure as what we have applied to the wheel cylinder, it's going to have to let that go and pump that back to the system. Why do you think it feels like it's pushing back at you when the ABS is operating, guys? It's because of that. Okay. Now, back to the sensors there. That's one of those things when it comes to ABS you should pay a lot of attention to, because if those sensors are dirty, or if the wires that go from the sensor via the suspension up to the harness on the frame, they're always bouncing and bending and they break eventually. So if there's a problem with those, then you get an ABS warning light on the dash. And an ABS warning light is usually associated with a problem with either the wire going down to the sensor or the sensor itself. Okay? Or you got some bad wheel bearings, or you got a bad axle shaft or something like that, depending on where the tone ring is located. Okay. So just a few things to be aware of. If the ABS sensor has slid out, if it's one of those ones that you just kind of push in like on the trucks, if it's slid out and it's too far away from the tone ring, it won't be able to generate the pulses, so you may have to close that gap up a little bit. Sometimes your ABS sensor is actually a permanent fixture in the wheel bearing or the hub on the vehicle. If that's the case, then you're changing the hub if you got an ABS problem. Brilliant design.
Like our truck ones, yeah, they're always fucking up. We can never get them to work, and you'd send it away and they'll fix it and it'll get fucked up again.
Yeah, it's a pretty tough operating environment. And depending on how much, bouncing around things are doing there. And if you look at the way the truck ones specifically are mounted, they just slide in, right?
They just slide in on ours.
Yeah, and then they vibrate out, and problems. Okay. So when it comes to ABS, like I was referencing already, the sensors, a very important part of it. The valve and the pump, those are the parts that actually operate the brakes for you instead of you operating the brakes with the brake pedal. And then there's going to be some electronics associated with that in the form of a controller. All right. When you're working on ABS, if you do have an ABS problem, safety's on vehicles, it won't pass if it has an ABS light on. Taking out the bulb or using a little bit of electrical tape to fix the problem, that's not how you fix ABS problems, guys. Okay, unplugging the module, that's not how you fix ABS problems. Figure out what's wrong and fix it. 9 times out of 10, it's just an issue with your speed sensor. It looks like we're going to talk a little bit about brake fluid here. Things to know, there's different types of brake fluids. Okay. If you have .3, .4, .5, use the appropriate brake fluid in the system. Don't mix and match. Be aware of that. It is not hydraulic fluid. I talked about that already. Hygroscopic. What does hygroscopic mean? That means it attracts water. All right. So it's a hygroscopic substance. If you take a look at a brake fluid reservoir, you'll notice that if you take the cap off or if you take the lid off of it, there's always that rubber bellows there, isn't there? The reason for that rubber bellows is so that as the fluid level drops, instead of it sucking air in to replace that fluid level, it's got that diaphragm or that bellows there that doesn't let any of the air that's getting sucked in actually touch the brake fluid. It's hygroscopic. If water gets in the brake fluid, then what happens is when you apply the brakes, the pressure goes up in the brake fluid, the temperature goes up in the brake fluid, and if there's any water in the brake fluid, it could get to the point where the water wants to boil, forming steam, which means that the brakes are going to feel like there's air in there because there's steam, air. What's the difference at that? So, have you ever heard somebody tell you to keep the container closed, the brake fluid, keep it closed tightly? That's why. It's hygroscopic. You don't want water in it. Brake fluid can be a pretty effective paint stripper. Just keep that in mind if you like to spill stuff all over the place when you're filling things up. Okay. So if you have nice paint finish, don't spill brake fluid on it, and if you do drip some brake fluid, wipe it up immediately, because it can cause paints to bubble and peel. Bleeding your brakes. Things to know. Start with the one that's furthest away from the master cylinder. All right. There's a couple of different ways to bleed brakes. You can have those vacuum bleeders. A vacuum bleeder, you don't have to have anybody in the cab pushing on the pedal. With a vacuum bleeder, what you do is you loosen the bleed screw with your bleeder hose attached. Your bleeder hose is going to be leading into the collection jar. That collection jar is going to have another hose coming out of it with a vacuum pump attached to it. And you create a vacuum in the system, and it literally sucks fluid from the master cylinder through the brake lines and wheel cylinder into your collection jar. You just watch the bleeder hose, then just stop and close the bleed screw as soon as the bubbles stop. Those ones are really nice to use, especially if you've got to do the job by yourself. If you don't have access to one of those, then you can do it the way that we showed you in the shop there. Basically, with that one, what you need to do is you put your bleeder hose on, and I'm a fan of using a bleeder hose, okay? I've done it many, many times without a bleeder hose, just by cracking the screw, squirt the fluid out, shut the screw, let go of the pedal. But a bleeder hose is nice because it lets you see if there's bubbles coming out while you're doing it, instead of just getting fluid shooting out in your eyes and you're not quite sure what's going on because you can't see anything anyways. Okay, put a bleeder hose on if you got one. So basically, crack the screw loose with the bleed hose on, but you have to have somebody in the cab to help you if you're doing it this way. Your bleeder hose is probably going to be going into a collection jar anyways. Somebody's in the cab, they're applying pressure to the brake pedal, and while there's pressure in the brake system, you open the bleeder. That's going to let the fluid vent out. You're watching for bubbles. If there's no bubbles, then you close that brake bleeder screw. Now, when the person in the cab is pushing the brake pedal down, oil's coming out. Make sure that you don't tell them to let go of the pedal until you've already closed the bleed screw. Because if they let go of the pedal, if they let go of that pedal before you close the bleed screw, it's going to suck air back in, and it's pointless, right? So get some pressure on the pedal, crack that bleed screw, allow the fluid to vent, close the bleed screw, have your guy in the cab let go of the pedal, and then pump it down. Do it 2 or 3 times. Even if you're not seeing bubbles, do it 2 or 3 times just to make sure that you're purging any air that may have been in the lines, okay? If you're going to be bleeding your brakes, probably, one of the most important things to realize, and I almost caught this happening, I forget exactly what it was, and I don't want to name names anyways, but just recycling the fluid that you drain back into the master cylinder. Don't get in the habit of doing that, guys. You may as well put new fluid in. because the fluid that's in your lines there may be contaminated, might have some moisture and stuff in it. So just dump that fluid that you're bleeding and put new stuff in. It's not like brake fluid is that expensive, and it's not like you're really, losing that much if you're bleeding it. But make sure that you check that master cylinder frequently so that you don't drain all the fluid out of it and then start pumping air into the system from the top. Then all your hard work is for nothing. You're literally starting from square one, right at that master cylinder. You got to bleed that first. Okay? So don't make that mistake. I've talked about bleeding the master cylinder. Pressure bleeding. In vacuum bleeding, I'm more of a fan of than pressure bleeding, where we're pressurizing the master cylinder and trying to force fluid through. The two-person method works very well if you know what to do and you got somebody who's doing what you tell them to in the cab. The vacuum, it works just as good as pressure. So again, this is not something that I've ever done or necessarily recommend. Brake lines, what are brake lines made out of? Steel or rubber. Okay. Brake lines are not copper. Brake lines are not whatever random fuel hose that you found that looks the same because it's black rubber. Brake lines are brake lines, and that's it. Okay. If you're going to make your own brake lines, you're going to need a proper flaring tool, and you're going to have to flare your brake hose using a double flare. Did you guys do any flaring?
No, we didn't. We didn't have
I've done
time.
it at the top, but
Okay. If we end up with a little bit of extra time here at the end of our brakes and wheel stuff that we got to do in the shop, if we have some time, I'll see if I can round up those flaring kits and you guys can have a crack at that if we got time. Okay, just so you can see how that works. Has anybody done this before?
yeah, I've done it at work.
Okay. So when you're doing a flare, a double flare for brake lines particularly, it's important that you do it right, because you are talking about something that is literally life and death if you don't do it right. Okay. So make sure you do it right. If you're buying brake lines that are pre-bent, awesome. If you're making brake lines and bending them, make sure that you use a proper bending tool. Those bending tools, sometimes they just look like a spring that you slide over the tube. Sometimes it looks like a pair of pliers with a bunch of rounded grooves in there that help you bend. Why is it so important to use a proper bending tool instead of just bending it with your fingers?
If you bend it, it'll probably weaken the pipe, like just by hand.
It'll definitely weaken it if you bend it and accidentally get a kink in it, because then the structural integrity of that pipe is gone, right? So if you're going to be bleeding, or not bleeding brakes, if you're going to be bending brake lines, make sure that when you do it, you use a proper bending tool, or something. Just be very careful that you're not creating kinks in the line, because if you do, yeah, it's game over. That line is garbage. Alrighty, brake boosters. What exactly is a brake booster? Usually in an automotive context, it's a vacuum operated diaphragm that is creating force on the push rod of the master cylinder, and it's controlled by a valve that's controlled by the brake pedal. All right. So the brake boosters. It basically reduces how hard you got to push on the pressure, or how hard you have to push on the brake pedal to develop pressure in the master cylinder and therefore in the braking circuit. Okay. So let's take this opportunity to do just a tiny little bit of math, okay? So a brake booster. A brake booster is basically a giant diaphragm, which is basically a piston, right? And if I have a diaphragm, or if I have a piston and I've got pressure on one side of it, it's going to develop force, right? Okay. Now I'm going to go through a couple of different units of measure with you guys. Inches of mercury. Do we know what those are? It's how we measure vacuum, right? And if we think about inches of mercury and pounds per square inch, 2 inches of mercury is equal to roughly 1 psi, okay? Because if you think about it, A full vacuum is right around 30 inches, right? And atmospheric pressure is right around 15 psi. Have you heard those terms before? Are you familiar with that notion? Yes, no? Take my word for it, okay? So here's the deal. With your brake booster, you basically got this thing with a diaphragm. Okay, it's this big giant can. It's got a diaphragm inside of it, right? And one side of that is hooked up to manifold vacuum, and the other side of it has a valve that controls whether or not we're allowing atmospheric air pressure to build up on this side of the diaphragm. And this whole thing is hooked up to my master cylinder. Okay, so here's what happens. Manifold vacuum is in this area here. And that manifold vacuum is also allowed on the opposite side of that diaphragm too, via a valve. Okay. If I have the same pressure on both sides of the diaphragm, is there going to be any tendency for it to want to move? No. Okay. Now, I also have that valve that was letting the manifold vacuum onto that side. It's also able to shut that off and allow air pressure on this side. So if manifold vacuum, let's do a little bit of math here. If manifold vacuum is around 20 inches of mercury, that's equal to about 10 psi, well, negative 10 psi, okay? And if I had, how big, let's say a 10-inch diameter booster, okay? So maybe something in a pickup truck, something along those lines, right? 10-inch diameter brake booster, well, how big, how many square inches, I should say, is there in a 10-inch diameter piston effectively? All I got to do is pi times radius squared equals surface area. You learned this with norm, right? Okay. And I know that this is going to be about 78.54 inches squared. Okay. So 78.54 inches squared. And I know that if I'm trying to apply the brakes and got 20 inches of manifold vacuum, that means I got 10 psi of force on 78. And remember, force is equal to pressure, 10 psi times area, 78.54, which is going to equal 785.4 pounds of force on the brake push rod. And you might be real good with your leg presses at the gym there, boys, but 785 pounds, do you think you're that strong? Okay. That's what manifold vacuum and pressure and surface area are doing to create a tremendous amount of force to help us with the braking. Why do you think it feels so hard to push on that pedal and you're barely stopping when the engine's off and you're trying to stop that vehicle? That you're trying to do what this thing was doing, just with manifold vacuum and enough surface area. And it's really interesting that that 10-inch booster with 20 inches of manifold vacuum behind it, and just atmospheric pressure on the other side, that's how much force it's able to develop. That's pretty impressive, isn't it? Yeah. So that's what brake boosters do. That's how they work. This is a close look at the valving inside of them to show us what's actually happening when they're working. Okay, so I'm going to jump right over to this one here, and we've got applied, we've got held, and we've got released. Okay, the released should have actually been at the top, but we're going to look at released first. Okay, so when the brake pedal is released, there is a valve. There's a valve, and it's right here that's connected to the push rod that your brake pedal hooks up to. Okay, and when your foot's off the brake, that valve is in a position that allows manifold vacuum that was coming in here to be on this side of the diaphragm and on this side of the diaphragm. And atmospheric pressure is not allowed into the brake booster. All right. When I'm applying the brakes, I'm pushing down on the brake pedal, right? And there's my brake pedal. So when I'm pushing down on the brake pedal, I'm actually opening up an atmospheric port and letting atmospheric pressure onto this side of the diaphragm. And I've closed off the vacuum port, so the only spot that's got any vacuum in it is the backside of the diaphragm. And obviously over here is my master cylinder. Okay. Think about this. When you shut your engine off in your vehicle and you put your foot on the brake pedal with the engine off, assuming there was still some vacuum in, you know that little whoosh that you hear? Okay. That little whoosh that you hear is air coming in by the push rod inside the cab. That's why you're hearing it, going through the atmospheric valve and filling up the backside of the diaphragm in the booster. That's what that little whoosh is that you hear. Okay. If you want to see, actually, no, I'll talk about that in just a second. Let's talk about what happens when it's held here, okay? We'll talk about this first, and then I've got one more thing I want to say. Okay, so if you want to see how this looks when everything is held in position, let's imagine that your foot has pushed the brake pedal down maybe halfway. That's enough braking force. You're not going to push it all the way to the floor. You wouldn't want the diaphragm to just keep moving and keep applying the brakes on you, would you? So when you hold the brakes, the diaphragm has got vacuum here, and it does have atmospheric pressure, but there's no more atmospheric pressure allowed through. Right? So just balances and holds there. And what's really interesting is when you're pushing on the brake pedal in your vehicle, assuming you have a vacuum booster on it, you're not actually pushing on the master cylinder at all. You're not physically pushing on it. You're operating the valve that controls the diaphragm that's pushing on the master cylinder. Think about that for a second. Okay. So when you're operating your brakes, you're operating a valve. If the valve is working properly, everything works as we want it to. If things are not operating properly, okay, let's say you got a whistling sound inside the cab all the time. Could be a leaking vacuum, right? Another thing is if the vacuum line that goes from the engine to the master cylinder here, that vacuum line obviously needs to be connected and it needs to be intact. The diaphragm inside needs to be intact. Okay. And if it's not, what can end up happening is you may not be able to build and maintain proper vacuum in here. The vacuum, manifold vacuum, is actively sucking air out through a check valve, because there is actually a check valve in here too, by the way. Okay. And that check valve, other way, there you go. So that check valve, we're sucking all the air out of this thing through that check valve and into the manifold. And then if there's very little manifold vacuum because the engine is running at wide open throttle or maybe the engine's off, then we have a reserve of vacuum in the booster. And the reserve of vacuum in there should be enough for 2 or 3 brake applications before it's exhausted. All right. So what you can do to figure out how well all of this stuff is working is you can shut the vehicle off and you can wait about 5 minutes and then try and pump the brakes and see if you still have vacuum assist. That'll tell you if the diaphragm and the check valve is in. Okay. The other thing that you can do is you can pump the brakes with the vehicle off until there's no vacuum assist available anymore. Put your foot on the pedal and start the engine, and the pedal should fall as the manifold vacuum builds. That tells you that the valve and the diaphragm and the booster and everything is functioning as it should. Okay. One other thing that I have ran across, and this one here, I had to scratch my head for a little while, and then I figured it out. Okay. We know that the master cylinder sits right here. Okay. Now, I had a vehicle one time that kept going through brake fluid. and the reservoir level is always going down. So I was looking for a leak because I figured for sure there's got to be a brake line leak. There's got to be, you know, a wheel cylinder that's leaking. Something's got to be wrong. There was nothing wrong. There was no leaks. It was still going through fluid. And then I got to thinking, well, where else could it be going? What do you guys think? What's that? Oh, you're muted there. I think I see Aiden trying to talk.
Sucked into the engine and burned.
Yep. So the pushrod seal and the master cylinder was leaking and allowing brake fluid into the booster. Okay? The brake fluid getting into the booster was getting sucked into the engine. And the way I diagnosed that was I pulled that hose off and I looked inside the hose and it was full of brake fluid. Okay?
I've seen that before too, yeah.
So when that happened, I changed the master cylinder. And as a safety precaution, I also changed the booster because I wasn't sure how much damage had happened to the diaphragm because of that fluid being sitting in there, right? So things to keep in mind, guys. I've gone over all of this. Hydro boosters. So we have done this on diesels. Usually, this is where we'd seen this is on diesel trucks, right? Where you have hydraulically assisted brake boost instead of vacuum assisted brake boost. Okay. So we take that big diaphragm with vacuum and we replace it with a hydraulic piston and oil pressure. It's still doing the same thing, pretty much the same way. It's just a different component with a different source of pressure. That's all it is. So when you got hydro boosters, basically you don't have brake boost unless the engine's running, unless you have electrical assist as well. Okay, and on some of the older hydro boosted, medium duty trucks, there was an electric pump that would kick in and help if there wasn't enough brake pressure available. So sometimes you get in those old 5 tons, you turn the key on, you hear that pump running. That's the electric pump that's building pressure for your hydro boost. I don't know if you guys know what I'm talking about or not, but sometimes you hear that on some of those older trucks. Okay. So hydro boosters, diesel engines, those things go together. Sometimes we used vacuum boosters with diesel engines, but then we had a vacuum pump on the engine, right? But here's one for you. Looking at our resident Ford expert. Why would an EcoBoost engine need a vacuum pump to help the brakes work? Turbocharged. Okay. If you have a turbocharged engine, that means you have positive manifold pressure, and that means you don't have vacuum available for those vacuum operated accessories in your brakes. Therefore, you need a vacuum pump. And conveniently enough, if I'm not mistaken, they located that in a really, really awesome spot between the back of the head and the firewall, didn't they? Yeah. So, anyway, I don't know if we're going to spend a lot of time talking about what goes on inside of a hydro booster, aside from the fact that it's a hydraulic piston. Okay, that hydraulic piston is operated by hydraulic pressure. That pressure comes from the power steering pump typically. When you push on the brake pedal, once again, you're not operating the piston, you're operating a valve. All right, and if you have a linkage and the spool valve inside of here, we're either going to let oil access the piston, or we're going to vent the oil out of the piston, or we're just going to block and hold whatever's in there. So that operating concept is the same as what we talked about for the vacuum pumps. Has anybody ever actually seen air over hydraulic or operated a vehicle with that?
I've seen it before, yeah. On an
Yeah.
old case tractor.
Oh, really? Okay.
Yeah.
Huh.
Some old cats have it too.
Okay. I know that, I'm trying to think where it was. I think it was on a semi I saw, but they were using something like this to operate the clutch instead.
Yeah, I've seen that too. Looks like it, yeah.
Yeah. Okay. But again, here, we have to have some way to control the air pressure, which operates it looks like a brake chamber because that's pretty much what it is. It pushes on the master cylinder. There's again, not that much to talk about here. There is one thing I forgot to discuss, and that's what happens when you have an internal leak in your master cylinder. I told you about an external leak that leaked oil into the booster. Technically, that's an external leak of the master cylinder. But let's say that my primary or secondary piston seals on my master cylinder were leaking. That means that when I'm trying to develop pressure in there, the pressure that's supposed to be in the brake circuit is leaking past those and back up into the reservoir. What's my customer complaint when that problem happens?
Sorry, what'd you say there?
Okay, so let me jump back to maybe a better picture here that's more representative of what I'm trying to talk about.
Probably brake pedal would go to the floor.
Yes. Okay. Oh man, I'm way up here. This will work. So as you can see here, if I had a leak where the pressurized oil that I'm trying to send off to my brakes is actually going back around to the other side because that's the seal inside the master cylinder was no good anymore. So what happened is I'd be trying to apply the brakes, and then when I build pressure and the brakes start to apply and that oil starts to circulate to the backside of the piston, my brake pedal just slowly falls to the floor. Okay, so if that problem happens where your brake pedal starts slowly going down to the floor, you better get out and look, because if you've got a puddle of brake fluid on the ground underneath you, it's doing it because the brake fluid is leaving the system. If there's no external leaks visible, then the reason it's doing it is because your master cylinder piston seals are leaking, all right, which is dangerous. I would say it's less dangerous than an external leak because at least you're not losing all your fluid, but it is still dangerous, okay? All right, so this is all done, and then tacked onto the back end of this lesson is just a little bit about electric brakes, all right? When it comes to electric brakes, we're probably talking about utility trailers and campers and things like that for the most part, right? So electric brakes, how do they work? Well, they're drum brakes, okay? They're drum brakes. And electric drum brakes, they work on the exact same principle as the self-energizing feature of hydraulic drum brakes. Okay, that's really what they're relying on for them to operate. So how does this work? Well, let's start in the cab. In the cab, you're going to have an electric brake controller. Okay, that electric brake controller is going to send a varying voltage down a wire that's hooked up to your electric brakes on the trailer. Okay, the varying voltage, if you have a really nice brake controller, is going to be proportional to the braking effort in the vehicle. Okay, or it might just be something that gradually goes up to a certain point and stops there. And then if you adjust the gain on your trailer brake controller in the cab, it's just going to increase the maximum voltage that we can get to. That's really all that it's doing. It's a varying voltage that goes to the electric brakes. Okay. Here's an explanation of the circuitry. Basically, you need a wire that goes to your trailer plug, and that wire is going to be for your brakes. There's going to have to be another one, which is going to be your ground, so that makes up the circuit. Okay. The breakaway switch, yeah, well, why don't we talk about that? So if your electric brakes are set up properly and you do have a battery, so there's going to be a little battery on the trailer, and there's also going to be a breakaway switch, and there's going to be a cable that hooks up to the tow vehicle. If the trailer were to come disconnected, and if the safety chains didn't actually hold the trailer, then that's your last line of defense, that little safety cable. When that safety cable pulls out, it closes a switch. And it closes a switch that takes power from the battery that's on the trailer and hooks it up to those trailer brakes. and it's on. As long as that switch is closed, it's on. So I'm sure that most of you guys would know what I'm talking about. There's usually a little cable with a clip, and if you pull that plug out of there, that should apply the brakes if your trailer battery is functional and if the electric brakes are any good. But that should also tell you that you should never leave that little plug out. You should always make sure that plugs in on the trailer. Otherwise, you're going to kill the battery on the trailer. Okay. That's what your breakaway is. Now, how do electric brakes work? This, and I also have the brake assembly downstairs that I can show you as well. Okay. So how do these work? Well, they're a drum brake and they got shoes. All right. Now, when you apply the brakes and when you send a voltage down to the electric brakes, what you're doing is you're energizing an electromagnet. And this electromagnet here is going to have a ground wire. It's going to have another wire going off to the brake controller. Okay. The stronger the voltage is going to this puck here, or the electromagnet, we usually just call it a puck, the more that puck is going to want to stick to the drum. Now, if you were to take a look at this from the other angle, just dead on the front, what you would see is, here's your brake drum, okay? And then you'd have this puck, which is this guy right here, and then you have your shoes that are pushing here. Now that puck, it actually sticks to a friction surface on the drum, which is the front of the drum, okay? And as it sticks to that, the rotation of the drum is going to drag this thing. Let's get some of this stuff out of the way. And it's going to want to cause it to rotate with the drum. And as it rotates with the drum, there is actually a torque arm here, or an actuating lever, and that's hooked up to what they call an actuating block. The actuating block is the same thing as an S-cam on an air brake system, okay? It's square, but it does the same thing as the S-cam does on an air brake system. When you twist it, it pushes the brake shoes apart, okay? So we change how hard we're applying the brakes by changing how much this magnet is going to want to stick to the drum and get sucked along, right? So that's one thing, but that's not the only thing that's applying the brakes here, okay? So when this block turns, it forces the brake shoes apart, but then that self-energizing action is going to force those brake shoes against the drums even more and cause the brakes to apply harder, right? Modulation on electric brakes is pretty crude, okay? It's just on the trailer, so we usually don't care too much, but it is pretty crude. So when your brakes really start to grab on you, you turn your gain down. And if they're still grabbing on you, then you got to let go of the pedal, shut them off, and then try again, right? It's kind of how it works with electric brakes. Electric brakes are drum brakes, and drum brakes need adjusting. And most electric brakes are not self-adjusting. So they do need to be periodically adjusted. And the same logic applies here as it applies to any other drum brake. You're going to use your drum or your brake adjusting tool. You're going to turn the star wheel, which adjusts the brake shoes until drag is felt. And then you're going to back it off about a quarter of a turn, eighth to a quarter of a turn until it's not dragging anymore. Okay? And you're good to go. So here we do have a nicer side view of that, showing the puck, showing the actuating lever, and showing how we do have some return springs on here. A lot of times with electric brakes for utility vehicles, although the brake shoes and the puck are all separately available, a lot of times you're just going to buy a vacuum plate assembly that has all of this stuff on it. It's $100, $200 maybe. If you go and buy just the shoes and you had to buy a puck, you're probably pretty close to that $100 you'd have spent on it anyways. You know, if your electric brakes aren't working, 9 times out of 10 is because the wires are broken. Okay. And if you're familiar at all with the quality of wiring that you're going to find on utility and RV type trailers, it's no surprise why those wires break all the time. Okay. So how do we check this out? Well, there's 2 ways to do it. My preferred method is to hop in the cab pinch my little lever there and try and drive and then go back and see how many wheels skidded. If I find a wheel that's not skidding, I got to figure out why though, right? So first thing to do is see if there's actually anything getting to that electric brake. Get out a voltmeter, get out an ammeter, just do some electrical testing. Okay? If I do have voltage getting to it, then I'm going to pop the drum off. And I'm going to have a look inside. Are the wires broken inside? Yes or no? Okay. Sometimes this puck, and I have seen them this bad, where it's been used for so long that that puck is worn down to the point where we get into the winding that made the electromagnet part of it. Okay, so it's just something that's been used for a long, long time. So when stuff like that happens, what do? You replace it. There's no rebuilding these things. You just replace when they fail. Ammeter, this could help us identify if we had a shorted out electromagnet. So between the amps and the volts, that'll tell you if you got power getting there and how much it's using. That's kind of where I want to leave that. Full hydraulic brake system. I think we're going to leave the bulk of this discussion for when you do your hydraulics in, I think it's level 3, you guys get some more hydraulics. When you get into hydraulics and powertrains, we'll talk more about this, okay? But when it comes to a full hydraulic braking system, a lot of the ways that the system works in terms of the actual brake valve is quite similar to how a air brake system works, okay? And for the sake of simplicity here, I'm just going to draw you one simple little diagram. Here, that canvas. So the notion here is that you have pressure supplied. That pressure is supplied to a valve, okay? And we want that valve to send oil pressure to the brakes. Now, how do we operate this valve? Well, this valve has got a spring pushing it up, and it has a pressure sense over here, okay? And then you have another spring on top that we have a foot pedal attached to. So what's going on here? Well, when I apply tension, or when I apply pressure to the spring by pushing down on the foot pedal, that's going to want to push this down, and it's going to want to let oil to go through, okay? And oil is going to go through until the downstream pressure gets high enough, and then we close the valve again, okay? And the harder you push on the spring on the top, the more pressure is developing downstream in the brake circuit, then the more braking force you have at the wheels. Have you ever wondered why on a semi, the harder you push on the treadle valve, the more it feels like it's kicking back up at you? Okay? Or even on hydraulic brakes on, say wheel loaders or haul trucks, rock trucks, things like that. On those ones with true hydraulic brakes, if you really hammer on the brake pedal, it feels like it's pushing back at you. And the harder you push, the more it pushes. It's because of this. It's because you're actually feeling the pressure downstream that you're creating by pushing on this spring. And it's pushing that valve back up at you. Okay?
On old, I seen that. I know what you're talking about. Like the newer stuff, like the electric stuff, you got potentiometers and all this other good stuff, and it doesn't really,
Yeah.
potentiometers, proportioning valves, and controlling solenoids. So
Oh yeah. Oh yeah. Okay. So there's a couple of items on the list here for troubleshooting, things to look at. We're very near the end of this. Okay, so right here we're talking about taking a look in the master cylinder when you let go of the brakes. Typically, when the brake piston, or sorry, the master cylinder pistons are all the way retracted, there will be a little bit of fluid that recycles from the line back up into the master cylinder. You should see that evidenced as a little bit of swirling. If there's no brake pedal free play, it can close the compensating port. If there's debris, it can close the compensating port. And if the compensating port isn't open, guys, what happens? Your brakes are going to drag. Okay. Okay, we've covered all of this already. Okay, we've covered swollen cups because of the wrong fluid already. Dragging brakes. If your brakes are dragging and you haven't had any recent service done to it, I would definitely want to take a look and see if you've got a bunch of dirt and brake fluid leaking out of the drum. That'll cause them to drag. Brake adjustment. Automatically adjusted brakes generally are pretty trouble-free. But if for some reason an automatic adjusting system is malfunctioning and causing a brake to over-tighten, and here's another one, this is more of an air brake thing, but it can also be a drum brake on vehicle thing. Remember, every time you apply the brakes, particularly in reverse for hydraulics and on air brakes, every time you apply the brakes, it's going to adjust the brakes to maintain the right clearance, correct? What happens if you make a full brake application and hold it, and you grab another notch and it adjusts and tightens up a bit, but it did that when everything was really, really hot and expanded. And then it cools down and your drum contracts, but your brake shoes had already adjusted themselves to that expanded hot drum. What happens now? Your brakes are going to drag. Okay. That is something that can happen. It's something to be aware of. Okay, spongy brake pedal. Normally we associate that with brakes that need bleeding because there's air in the system. All right. If your rubber lines are doing this and they got these big blisters on the side of them, every time you hit the brake pedal, they just expand. And the pressure isn't really making it to the pistons and the wheel cylinders. It's being used to expand that rubber line. It's a very dangerous situation. Deal with it immediately. Air in the system, bleed your brakes. Boiling, well, that means there's moisture in there. So what do you do there? Well, you flush the brake system. Okay? And when you flush the brake system, what that means is you replace all of the fluid with new fluid. Now, does that mean that you siphon everything out of the master cylinder, pour some new stuff in the top and call it quits? No, you have to flush that new stuff all the way through. So what you should do is you should empty out the master cylinder as best you can, fill it with clean brake fluid, and use a vacuum bleeder to suck that fluid all the way through the system and out your wheel cylinders. Or you can do it backwards and pump new fluid in from the bottom up. But either way, replace the fluid in the system. How do you know brake fluid is bad? It looks like the stuff in the Ford. Okay. What did the brake fluid in that Ford look like? It was almost black. That's how bad it was. Pull to one side during braking application, bad brakes on one side. Wrong size wheel cylinder, I don't know if that's really much of a possibility these days, but yeah, I guess anything's possible. Alignment, absolutely. Tire pressure is something that gets overlooked way too easily. Okay. Well, that actually brings us to the end of this. Okay, so I'm going to